So one way is by distributing with the fractions right now, and then somewhere later doing the least common denominator when you try and get rid of the denominators, right? The other way is doing that first. And I'm going to show you both. Now, you don't have to write down both. If you like one way better and you think the other way is going to confuse you, just don't look at the other way, all right? Just look at the way you like. So here's the way to start if you're going to distribute first. You're going to distribute first, and then the other way is you're going to distribute later. Okay? So distribute first looks like this. The 1/6 goes here and here. So 1/6 n looks like that, this rather. And then when you do 1/6 times 12, remember 12 is over 1. And when you multiply fractions, you go across the top and across the bottom, right? That would give you 12 over 6, which is really what? 2, right? Okay. And then if you're distributing this 1/4, that's 1/4 n plus 1/4 times 8 over 1. You go across the top, across the bottom. That's 8 over 4, which I'm going to simplify to what in a minute? 2, right? And then you have that minus 2. And then just simplifying the fractions gives you this next. And what can I simplify else here? Plus 2 minus 2. Gone, right? That's 0. So then I have this. And that's fine and dandy. In a minute, I'm going to show you how to take care of those denominators, okay? The 6 and the 4. Now, let's say that's not how you started. Let's say you started with least common denominator first thing. Here's how that would look. You find the denominators as they're written right now. I have a 6 and a 4. And this process is called clearing the denominator. We want to get rid of it. So you need to think of a number that's bigger than 6 and 4. It's something we call a multiple. What number does both 6 and 4 go into that's bigger than it? 12. But also 24, also 48. There's bigger numbers that would work, but 12 is the smallest one. Okay? So you say, okay, the least common denominator is 12. And you remember me saying to multiply both sides by 12. Because whatever you do to the left side, as long as you do it to the right side, you keep it in balance, and it's like legal math, okay? So 12 times the left side, 12 times the right side. And this is where you would distribute if you were this person, okay? But here's the thing. Where do you distribute the 12 to? There's like a lot going on that left-hand side. But think about it like this. It's really a multiplication of 3 things. It's the 12 times the 1/6 times this group, which is n minus 12. And when you're multiplying 3 things, you go left to right. You multiply the first 2 things. 12 times 1 over 6, so that's 12 over 6, which is what? 2. And then you multiply by the third thing. Let me tell you what you do not do in this case. You do not take 12 times 1/6 and times n and times negative 12. That's too much multiplying. Okay, you're just going left to right. You multiply the first 2, you get that answer, it's 2, and then you multiply that times the third thing, which happens to be a group, the n minus 12. Now, on the right-hand side, it looks a lot like the left-hand side. There's a fraction times a group. What's the main difference on that side? It's different from the left. What's extra about that side? The minus 2, right? So now when I distribute 12, this first piece is going to work just like I just said a second ago. I'm going to do 12 times the 1/4. What's a fourth of 12? 3. and then times the n plus 8. So I'm going to distribute 12 to this thing, but I also have to distribute 12 to this thing because it's a separate term. And 12 times negative 2 is negative 24. So now in this version of the problem, I have cleared all the denominators. But I haven't done that yet down here for those of you who distributed first. But it's the same number. It's still multiplying both sides by 12. A sixth of 12 is 2. So that goes here and here. 12 times negative 2 is negative 24. And then a fourth of 12 on the right-hand side is 3. Okay, so take a minute for those of you who needed that little bit of help and finish the problem depending on where you started. There's 2 different versions here. So either way, you get n equals negative 24. Right. So it's kind of a hefty problem. There's lots of things to keep straight. There's negatives, there's fractions, there's everything in there. Right. But are there any questions that need to be cleared up now that we kind of went through all that? All right. So that was part of Friday's lesson. So Friday's lesson, we solved equations, and we had 3 different kinds. We had ones that looked like this, that started out with just plain old distributive properties. We had ones like our original problem, which had fractions as well, and then we had ones with decimals, right? And we learned that trick about if you want the decimals to be converted to integers, you multiply by 10 or 100 or whatever you need. But that decimal thing is just a trick. It's not a trick, it's just a tip. And if you're comfortable with decimals, you don't even have to do that at all. So speaking of Friday's lesson, the homework, were there any homework questions? That's not a great quality here, but I can go over any of the problems if anybody. I boiled it down to 2 decimals, 2 fractions, 2 distributives, and gave you answers to all the rest in case you wanted extra practice. I mean, I know how y'all do on your weekends. You're like, I need some extra math practice, right? So I didn't want to disappoint you. I gave you those extra answers in case you do like that, and I wanted you to be happy. I aim to please. Homework questions? Anybody? Okay. If you haven't done it, probably going to have a skill check tomorrow, probably going to have a skill check on Wednesday. You have what coming up on Thursday? A quiz. Okay. Okay. Today's lesson. Today's lesson. I'm Dawn, by the way. I have to give myself reminders. I'm gonna forget that. I'm gonna show you this thing. Today, what we're doing, if you look at your we will statement over here, we will solve equations for specified variables. So still solving equations, but here's how today's lesson is different. Friday's lesson, there was one variable and we were solving for it. We got like x equals 2 or something like that. Today we have formulas like this, where there's many different variables, and we're going to solve for one of them. And I'll tell you why you might want to do that here in just a second. But in this case, over here on this we will board, this is a volume formula. What variable is this already solved for? Meaning, which variable is already isolated and all by itself? The v, right? So this formula is solved for volume. But it's asking me to solve for what? H, which is height. And the reason why you might want to do that is in the original form, where v is by itself, you could, in a real world situation, manipulate your r and h, your radius and height, and see how that will affect v, right? Like you could plug those in and then see immediately the way it would make the volume get higher or lower or whatever. You'd be optimizing for that variable. But let's say instead you wanted to know how volume and radius affected the height. You could resolve the equation for h, and then v would be over here somewhere. Change your v, change your r, and you could see in real time how that affects your h. And so that's why it might be helpful to be able to solve for a specified or specific variable. And the thing I want to show you is my husband's engineering book. So my husband is, you don't even need for every single problem. It says, use factoring out the GCF if your variable appears more than once in your equation. And the very first example will do that, but not all of them will. Like, for example, on the We Will board, if I'm solving for h, how many times do you see h in this formula? Just the once, right? So this tip wouldn't even apply for that kind of problem. Let me show you the very first example. It does, though. So I have this formula, and all of these are real-world formulas. I don't exactly know what they mean or anything, but they tell you, like, this is for retail somehow. So S equals P minus PD. We're going to solve for P, which means I need P all by itself and isolate it. But there's two of them here. And here's where the problem might arise. And you don't need to write this down. I want you to just kind of watch for a second. You might look at this and say, okay, here's a P all by itself. I'm going to get it even more by itself by moving the PD over. So that would give me S plus PD equal P. And I might feel very accomplished because this P is all by itself. But how come I haven't actually solved for P? Yeah, there's one on the other side. I don't really know what P by itself equals. I can't solve for P and still have P on the other part of the equation. So this is why we have that tip about the GCF. So I'm going to start by taking the GCF on the right-hand side. Do you remember what that stands for? Okay. It's what multiple terms have in common. And factoring it out is kind of like doing reverse distributive property. So I'm going to do that on the right-hand side for the P. So both of these terms on the right have P in common. And I'm going to write that down. That's their GCF, okay? So this is the GCF. And then in parentheses, I'm going to put the quote-unquote leftover factors. When you divide P out of everything. So when you do regular distributive property, you're multiplying through, right? Well, if you're doing that backwards, what are you doing? You're dividing out of everything. So I'm going to take each of these terms and divide out a P. And I'm going to write that leftover, the quotient part, right here. So in that first term, when you divide a P out, what are you left with? If you divide P out of P. 1, right? What do you think is the most common mistake that people will put right there? 0, right? They feel like there's nothing left. I'm going to tell you in a second how you can figure that out for yourself if you did it right. And then minus is next. And then PD, we're going to divide a P out of there. What's left over? D, right? If you're ever unsure about you did that correctly or not, or you thought a 0 was supposed to go there for that 1, you just check yourself by doing distributive property, right? When you go to distribute this through, you should get back what you started with. If you had put a 0 here and checked yourself by distributing, P times 0 would have given you 0, and you would have been like, oh, I was supposed to get 0. I was supposed to get P. What do I need to put there to get the P back? Okay. So reverse distributive, and then check yourself with regular distributive. Okay. So here's where we are. We have S equals P times 1 minus D. So I need to get P all by itself. Right now it's times something. What's that thing that is being multiplied by? Or I should say, let's make it simpler, a simpler example. If I had just this, P times 3, instead of P times 1 minus D, and I said, solve for P, what would you do? Here. Divide by 3, right? You would divide by 3. But instead of 3 over here, what do I have? 1 minus d, that whole thing, that group. And so just like here, you would divide by 3, except over here, you're just dividing off the group, the 1 minus d. So these cancel, leaving me p all by itself there, equals s over 1 minus d. Okay. And once these click for you, you'll see that they're, even though they're kind of scary with all the variables, they're really pretty straightforward. Once you wrap your mind around that, we're not actually getting numbers or solving anything. We're just moving stuff around to get the specified variable all by itself. Questions about this one? Okay, this goes with homework number, let me see. I have it written down somewhere, I just don't have it memorized. Homework number 37. All right, the next example. There's a lot of numbers in this one. Let's talk about the difference between them. This d with the superscript of 2, that's an exponent, right? That means d squared. That's actual math, right? D times itself. But these two numbers right here, these are subscripts. This p has a This p has a subscript of 2, and this p has a subscript of 1. Those aren't math. Those are just telling you that they represent a similar kind of information, whatever p stands for, but they're still a little bit different. So the 2 differentiates itself from this one with a 1. Okay, that's not math. So this is set up like a proportion, and generally students, they remember some kind of trick they learned back in middle school. They don't quite know how it goes, but they mess up. But this is what I'll see on their paper. What are they trying to do here? They're trying to cross multiply, right? The butterfly method. And so and this isn't the only way to do this problem. And I mention it just because I will see a lot of mistakes with this on the paper. So I figure it's worth talking about. Here's how cross multiplying works, because I know when you don't do it regularly, you forget what the trick is. That means you multiply across one diagonal. So if I was going upper left, bottom right, that would be CD squared. And it equals the other diagonal. And that's how you cross multiply. If you don't remember that tip and you just think to yourself, how do I get the denominators out? And you just multiply both sides by the bottoms, you'll get this to the same place. What is it that we're trying to solve for? What are we trying to isolate and get all by itself? P2. Okay, find P2 with your eyeballs. Do y'all see it? Yeah. Okay, what's currently with P2? All right, how do I undo that? How do I undo that? P2 times P1, divide. Well, we want P2 by itself, so we want it to stay there. Divide by P1. So P2 equals CD squared over P1. We probably need problems that don't require me to say P so many times. Right? I'm thinking. Or PP in the same problem. Probably not great. Questions about this one? That's it. Like, we're done. We got P2 all by itself. Oh, this goes with homework numbers 41. Okay, good. Not so bad, right? Getting the hang of it? They're really not that bad once you get the gist of it. All right, so now we got this one. This is a geometry one. So we got area equals height times the sum of two bases all over 2, right? 1/2 height times the sum of the bases. What are we trying to get all by itself? What are we trying to isolate for here? H, okay, do you see H with your eyeballs? Okay, there's a few things happening to H right now. There's a division by 2, which we can take care of. And then there's a group that's being multiplied, the B1 plus the B2. A lot of times, so I'm going to tell you something wrong. This is wrong. Well, it's not that it's wrong. It's just going to require more work on your part. Don't do this. Don't distribute the H right here. Here's what would happen if you did. But what did we say at the beginning of the lesson when the variable you're trying to solve for is in more than one place? What did we say to do? GCF it, right? Which is pretty much the opposite of what I just did. I just have to undo what I just did because I told you it's reverse distributive, right? So resist distributing right here, even though it really feels like that's what you should be doing. Don't. Here's what you can do instead. You find the H right here, and you just undo the two things happening to it, the divide by 2 and the multiply by this group. Which one do you want to take care of first, the 2 or the group? The 2? Okay, how do you undo divide by 2? Multiply both sides. So the 2's simplify on the right, leaving me H times the group, B1 plus B2, and then 2A on the left. So I'm trying to get H all by itself. Right now it's times the group. How do I undo that? Divide by the group. The group is the B1 plus 2, B blah, 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 blah. Okay. Not too bad. Even though there's variables everywhere, we're not scared of this problem. This goes with homework numbers 45, or just number 45. All right, so on the back, we're going to level up a little bit. Does anybody need this up anymore? All right. So on the back, we have this. This is from physics. S equals 1/2 gt squared plus vt. What are we solving for? G. So we want to get it all by itself. So find G with your brain so you can sort of start making a game plan. Let's talk about all the things happening to G right now, because we're going to have to undo them. Times 1/2 times t squared plus vt. In these kind of problems, I like to encourage you to think about doing PEMDAS backwards. And I'll show you what that means, backwards. So getting G by itself, if I were to talk about undoing addition or subtraction first, right, going backwards, what is my addition or subtraction here? The plus VT. I want to undo it. So how do you undo plus VT? Subtract to both sides. Okay, that ain't no thing. We can do that. Okay, let's look at the G again. Let's not lose. So we're still working with the G. I will lose a lot of students right here because they see the t squared and they immediately want to start throwing in square roots. We don't have to do square root at all, period, in this entire problem because I'm solving for G. Which of these variables would require me to eventually do a square root? T. That's exactly right. Okay, only if this problem had said solve for T would I eventually need to square root. But I don't have to do that all here. So right now I have G times 1/2 and G times t squared. So those are both multiplications, or maybe you're thinking about this as divide by 2, but still we're going to undo multiplication or division next. There's 2 of them here. You can do either one you want to do first. Would you like to undo 1/2 or t squared first? Okay, how do you undo times 1/2? Divide by 1/2, which is the same as multiplying by what? 2, right? Keep change foot. Multiply by the reciprocal. So the half and the 2 undo each other, leaving me gt squared. And then on the left-hand side, I have 2 times everything on the left-hand side. What do you think I'm going to add in here to show that it's not just 2 times the s only? Parentheses, right? Almost done. G is not quite by itself. Times t squared. How do I undo that? Absolutely. Divide by t squared. So those cancel. 2 times the quantity s minus vt over t squared equals t. And this is like homework numbers. Homework number 47. And we have one more problem. This last problem you've seen a lot over your algebra career because it's a linear equation. And we've done a lot of solving for y when graphing linears. When we solve for y, that means we are generally putting it in slope-intercept form. Remember mx plus b. And that way your b is your y-intercept, and then use your slope to get your second point. Please notice this isn't asking you to. You don't have to do y equals mx plus b if you don't want to. Just solving for y is sufficient. But before we even begin, I want you to clear the denominators first. What least common denominator would clear the 3 and the 9? 9, very good. But what else could you have used? 18, 27. 18, 27. So all of those are multiples of 3 and 9. But the smallest is 9. It'll do the job. So start by multiplying both sides by 9. Take a minute and do that and simplify on your paper. You don't have to go farther than that step if you don't want to, but at least do that before we go on. So distributing the 9 through gives you, so you're doing across the top, across the bottom. So that's 18 over 3x minus 63 over 9y equals 1 over 8, or sorry, 108. 18 divided by 3 is 6. 63 divided by 9 is 7. Okay, so make sure you're here before we move on. Your math didn't go rogue somewhere. So then from here we want y by itself. So this is a good PEMDAS backwards problem. You find the y. And here's what's happening to the y right now. Times the negative 7 plus the 6x. So if you're doing PEMDAS backwards, which are you going to undo first? The 6x, right? Right now it's positive, so how do I move it over? Subtract it. And then we only have the last step, divide by the negative 7. And you can rewrite this several different ways. I would take it just like this, even with the negative 7 on the bottom, although I personally would bring the negative out front. If you're going to break this up into 2 fractions, be careful with your signs, because when you break it up with the x, that's a negative divided by negative, which is positive. But then when you break it up with the constant, it will stay negative. Questions on that one? Okay, this one goes with homework numbers 51 and 53. And I have the I will problem that I want you to work on real fast, and I'm going to pass back your quizzes while you do that. We'll go over the quizzes tomorrow, okay? I always go over quizzes, but we are short on time today. So try this problem while I pass back your quizzes. You want to solve for H. Okay, so if you're thinking about PEMDAS backwards for this problem, really there's no addition or subtraction to take care of. It's just multiplications and divisions. And so you could take care of this all in one step, but I'm going to show you two steps. We'll deal with the fraction separate from the other coefficients. So I'm going to start, we're looking to isolate H right here. So the things I need to undo are the times 4/3, the times pi, the times r squared. So I'm going to undo this whole section first by just dividing it off. So I have v over pi r squared equals 4/3 h. And then from here, I need to undo times of 4/3. The way I like to think about it is multiplying by the reciprocal. Because these cancel out right here, leaving me h. And then when I multiply across the top and bottom of this fraction, I get 3v over 4 pi r squared. Some people might think about it right here at this step as dividing both sides by 4/3. Just remember that dividing by 4/3 is the same as multiplying by the reciprocal. That's your keep change flip. And that will get you to the same spot that I did. And that is one of your homework problems.